Okay, you're going to start on the home screen on your iPad. Scroll over to find video physics. Should be somewhere on here. Here it is, video physics. And you're going to hit the plus button to add, take a new video, and should just bring up your regular video app here. So we got Mr. Chavez up there on the second floor of the Corkins building, and there's Hudson. Hey, Hudson. Okay, so you want to get Mr. Chavez kind of in the top of the frame, and notice that we've got the meter stick right there on that center pole, kind of behind Miss Williams. So, okay, here we go. I'm gonna hit record, and I'll tell Mr. Chavez to drop it. Go ahead and drop it. Okay, now you would stop that, you'd hit use video, and you can do another one. We'll go ahead and go back to experiments, add one more, take video. And he'll do his second trial here. Ooh, this is the big one. Here we go. And go ahead and drop it. Okay, so you want to keep this. Thank you, guys. You want to keep that as level and motionless as possible when he. Oh, there's our stop. You want to keep it as level as possible. We'll hit use video again. And what you're going to do now is use this cursor to track the motion. So you can go a little bit forward here until he just starts to drop it. You want to make the size of this cursor basically the same size as the ball that he's dropping. So here we go. It's about the right size. There we go, right there. And you want to find the point at which he just releases the ball. So I'm going to back it up just a bit here. And what you're going to do is put the cursor over the ball, and then you tap on that kind of shaded white section. And every time you tap, it adds a plot on that video. It's advancing the video forward by about 0.04 seconds every single time you click the dot. And what you should hopefully notice is every time you click that dot, seems to be dropping a little further. That should not be a mystery to you. That is because it is accelerating. It has not yet reached its terminal velocity. You should understand that from our textbook Terminal Velocity Lab. One of the things that's really important is that you are very precise in putting the cursor over the ball every single time you do that. That's kind of the major control variable. And it can be a little bit hard with the blurriness of the ball sometimes, but give it your best shot. So you're going to keep on. Okay, so now the next step is you can check your graph by clicking up here in the top corner, and you can scroll over to this graph. This is the one we care about. And then it looks pretty good. You'll notice down here in the bottom right corner, it looks maybe a little bit funky, but we've got a position time graph on the top and a velocity time graph on the bottom. We'll be talking about that a little bit more, about what's going on with that. So those look nice. We're going to import those into Logger Pro in a little bit. Before we do that, we need to set the origin and scale. So go from points to origin and scale. Notice I did put that meter stick down there to show you what 1 meter is for the video. But what I'm realizing actually works better is if you directly measure how far your partner drops the ball. So setting the scale basically is telling the video how far did the ball go, or because it can't tell how many meters that is. So shout out to Cece, thank you for helping me with this. What you want to do is you want to have the center of this sphere, or kind of the end of that line, touch the bottom of the ball when your partner's holding it stationary before they drop it. That's your frame of reference, because the bottom of the ball is what hits the ground. That's what you want to do, and then go ahead and advance the frames until the ball hits the ground. So right there, it might be a little bit difficult to get it exactly stuck on where the ball hits the ground, so it doesn't matter if the actual frame isn't there. I can see where it is right there, so I'm gonna go ahead and move. There we go, I got it good. Right about there. And CC helped me measure this. This was 6.3 meters. there we go, 6.3 meters. So you'll set that. And now Logger Pro is going to know exactly how fast that ball was dropping. So now you're going to go and export this. You want to export the data file, and you can just mail it to yourself and your partner. So go ahead and type your email in there and send it. And that's it. Okay, so now that you've sent this email to yourself, you'll notice there's two interesting files, a CMBL and experiment2.mov, whatever your experiment number is. If you download the movie file first and then the CMBL, that's the Logger Pro file format, it'll load your video actually into your Logger Pro file, which is kind of cool. So I already did that, so if you want to download that, you can. And then what you'll see when you click on the CMBL file is your video that you took along with the points that you took. So it's kind of cool. As you move your cursor over here, you can see the position and the time at every moment and where the ball is as it is falling. Now, one of the first things you're going to want to do, go over here, click on your X coordinates and just delete those. That's because the X coordinates are how much the ball moves side to side. Ideally, it fell perfectly down, but it might waver a little bit. We don't care about the side-to-side motion. We only care about the Y, the up and down motion. So we got rid of that. But now you've got a really nice position time graph and velocity time graph here. So one of the things you're going to do is you're going to be examining some of these points, maybe with the tangent tool, like we were doing in the textbook drop lab. We will also be going down here to the velocity time graph and thinking about what we see here, starting with the linear fit function. So that's basically going to give you a best fit line on that graph. So you're going to do both of those. And that is it.